So Hospital Supply Corporation is 49 years old, and recently we will be having our just a second, sorry. Yes. So Hospital Supply Corporation is completing its 50 years of existence as a service provider in the healthcare industry of Pakistan, and we will be completing this journey next month, inshallah. So our key products, so basically we are a family-owned company, and we started in 1973, and in 1984 we started our electromedical division, starting in nephrology and urology, and then we diversified to other hematology and diagnostic products. So we have emerged as one of the most trusted names in quality products and reliable services in the healthcare sector of Pakistan, now serving for more than 50 years. One of the key milestones that we achieved was our joint venture with Otsuka Pharmaceuticals Japan and the Feroz Group, the Feroz family, in 1988. Now I'll just show you a little bit about our key products. So this is Imicor. So the large machine is a Neo Iris, and the smaller one is the Echo Lumina. And Ms. Desiree will be sharing more about these in a short while. Then our products also include some diagnostic products like electrochemiluminescence, then immunofluorescence assay, rapid tests, and then some equipment for cell separator, cell salvage for intraoperative use, then thromboelastography, blood filters, and then we have a separate division for nephrology, which includes dialysis machines, RO plants, dialysis reprocessor, and hospital furniture. And then urology, we have some equipment like lithotripsy from Donier and urodynamic products. Then we have some products in our regenerative medicine, where we have products that are used in the ICU and CCU. Then these are the Otsuka products that we also distribute in Pakistan, including IV solutions and some therapeutic drugs as well. Then these are our range of some pharmaceutical and surgical products, YMS brand. Then we have a separate water division for industrial and specialized use. And these are some of the key principles that we represent. One of the main focuses that we have is that we have a very strong team of support engineers who are factory trained and who work 24/7 on standby to solve any problems that the customers may be having. We have a separate distribution setup and Dynamics ERP. Then we have a separate cool chain system for logistics end-to-end where products come in. So we have a complete cool chain maintenance from the time that we receive them in Pakistan till the time that they're delivered to our customers, which are labs and hospitals and blood banks. Then this is our major coverage, where we have our setup in Karachi, where is our head office. And then our branch offices are in Multan, Lahore, Islamabad, and Peshawar, where we have our own offices, warehouses, as well as workshops, where the engineers place there to provide timely services. These are some of the office locations that we have. And now I will ask Ms. Desiree to please share the profile and the presentation of Imicor. Thank you. Screen share I have to turn off screen share first. Okay. My direct Desiree. Okay, Desiree, you are the host now. Please start your presentation. Thank you.
Yes, now it's working. Okay, great. So give me just a second. I will share my screen. Okay, so I hope you all can see my screen and you can hear me. Thank you for inviting me today. I am Desiree Agosta. I'm working with Immucor this year for 14 years, and I'm the technical marketing and sales support manager for your region and working together with HSC for your market. So we will speak today a little bit about blood bank automation solutions we have, and also about our Capture solid phase technology, which is our technology for all the Coombs testing we provide. So we start with a little bit about a general information about Immucor. What do we have? Yeah, we are your compatibility partner with all the different things we offer. Let's start with our name. The name Immucor is coming from the IMM, what means we started in the immunology business years ago for transfusion. And finally, after some time, we also added to our portfolio molecular testing and also data management solutions. So we are with our customers in the healthcare sector, in hospitals and the blood banks. In our portfolio, we have the transfusion portfolio, about what we talk today a little bit more. That means we have all the traditional reagents and also specialty reagents for transfusion, the Capture technology with the solutions, and also a bioarray solution, which is for molecular testing. Additionally, for that, we have the ImmuLink system, which is a data management system, and also a platelet portfolio. In addition to that, we also have transplant and hemostasis products. We don't focus on that today. Today, we will speak more about transfusion. So Immucor has installations all over the world. We have global installations for our instrumentations, more than 1,000 for the Neo family and more than 1,400 for the Echo family. And as you see on the map, we are in all the countries represented, which are here highlighted in blue. Our history started already 40 years ago, what means in 1982, Immucor was established. And over the time, we had first semi-automated instruments. Then we had 2004, the first fully automated analyzer with the Galileo. And then the development went into the newer instruments, and we added also some more products. And finally, we talk today about the Neo Iris and the Echo Luminar, which are the instruments we want to present to you today. In our transfusion portfolio, we have the instruments, then we have the ImmuLink system, which is a result data concentrations, and also for the okay, I just got a message here that someone is waiting in the presentation, but I don't see that information. I can't allow people, sorry for that. I don't see where I can accept people to let them in if they are waiting in the waiting line. So let me see here. No, I don't see anyone waiting. Okay, I will go on with the presentation. The sharing is still on. I hope you can still see it. Okay, sorry for that. Yeah, what we have are the instruments, the Ecolumina and the Neo Iris for our transfusion instrumentation, and the Imulink software with the data result concentration, and also the possibility to connect different laboratories with each other. So if you have, for example, a main laboratory and satellite laboratories, you can connect all of them together and see all the data in one software. Okay, I need to share again. So I hope the image is back. Okay, so yeah, as we always said, we have also traditional reagents for the blood bank, for manual usage, molecular solution with the bioarray, and also the platelet portfolio. So we talked today more about our capture technology, about the Neo Iris, our high throughput analyzer, and also the Ecolumina, our low or mid volume instrument, and look further into that. If we look for some reference accounts, the US News and World Report publishes every year the 10 best hospitals in America. So, and as you see, we are present in all of them. So there are more reference sites all over the world, but yeah, that's the ones from America. We also have new investments made over the last years, and still are going on with that. So the investments we did for new innovation over the last years was especially in software and with our Imulink in the data management solutions, and also new investments and still ongoing process in our NGS solution for the MIA-FORA system. From a quality standpoint, we have 5 different certified sites. So that means for the manufacturing side, we have Dreieich, Germany, where I'm located. Then we have in Canada 1 site, and 3 US FDA regulated sites in the US, which are in Atlanta, in Waukesha, and in Warren. Additionally, we have all the certificates which are needed. So the CE mark, the FDA mark, we are ISO 13485 certified, and also the new IVDR, which is now rolled out in Europe, is also the first steps done, and an ongoing process. So there is also already a certificate for the main products available. So finally, it's a systemic approach to from a manufacturing standpoint to have a consistency for supply chain manufacturing and providing the products to you. And we focus here also on our supply chain, on the environment and quality controls, and the manufacturing, and for sure also training our people. So I will now go on with the explanation of the instruments. For the Ecolumina, which is our small or mid-size instrument, it's still the smallest global footprint we have in the market. It's a benchtop instrument, and will provide you full automated menu for everything. That means we have everything present in this benchtop analyzer for a full automated and walk away system. You just load the samples and you start, and everything gets finished without any further intervention from you. So to explain it a little bit further, we have here a Fluidic system with the user interface with a touch screen, monitor and mouse, and there's a computer connected as well with Windows 10. We have a pipetting system with the sample loading bay and the reagent loading bay. We can load on this instrument 20 samples at a time, and also all of our reagents needed. And inside the instrument, we have a wash station, so we wash our plates, a camera reader, a centrifuge, and the incubator, and a loading bay where we load our strips. We are working on our products with a microplate technology, and the strips get loaded into the instrument. And to give you a little bit more visuals for that, I will present the video to you. So the instrument is available with a container which can be filled and emptied while it's running. You don't have to interrupt your work for that. The containers are just here. And here our sample loading bay provides you the possibility to have a continuous loading on the instrument. That means as soon as the samples are pipetted, we can load new samples, and can always reload new things. So on the samples, we load the samples into the racks and put them into the loading bay, and we can also use different kind of racks for different kind of sample tubes. And the reagents are also loaded on the instrument. We are working with very small amounts, and we load everything basically in the morning and then run the samples from there. So that's the small size instrument which we have. We can have here, oh, no, sorry. We, okay. Great, so I can't mute it anymore. Okay, sorry. So I just need to go on. Okay, so I try to start it again from where it stopped. So let's go on here. No, it's okay. Let me play that again. No. Okay, great. No. Okay. Technical issues. Let me just restart that. Okay, so I can't share the screen. Can someone make me the host again, because it got... Okay, Now we are back. Great. Okay, sorry for that. Good. Okay, so let's go on. Yeah, for the instrument, we can load our samples and our reagents on the loading bay, and we can continuously load samples and also microstrips if more are needed during the day. Usually we load everything in the morning, and then we just load more on request if needed. The instrument can be positioned on any table. It's not quite heavy, and the space is quite low, which we need for that. We have a very fast turnaround time, so it's also for on the market one of the fastest instruments to run type and screen, and also cross-matching is possible. We get the real-time results. What does mean real-time results? That means you can see already, for example, the blood group while the screen is still running, and then you can already search for the right donors you need to match for your patient, and start with the cross-match in the next step. We can connect the instrument bidirectional to the LIS system, and we also have a broad test menu which is available for the instrument to reflect your needs you need in your laboratory. So this is the test menu which is available on the instrument. We have for blood grouping ABO-RH assays. We can run also neonate samples and also cord blood. We can run the donor confirmation test, ABO retyping if needed, phenotyping for RH and KEL, IgG cross-match, IgG for DAT, C3D, DAT, weak D, antibody screening with a 3-cell panel, and also antibody identification. And Immucore offers 3 different panels. One is the primary panel, and if more panels are needed, we can also run a D positive panel and a D negative panel to exclude more antibodies if it's a difficult case. So now I would like to introduce you the NeoIris, which is our high throughput, fully automated analyzer. And here we have also a broader test menu for the high volume labs. And to show you a little bit more about how the instrument is built, we have here also a touch screen and the user interface with the keyboard, mouse, and also the computer connected. Also on the NeoIris, our computers are right now with Windows 10, and we also provide an antivirus program on the instruments to build some safety here for you. With the instruments connected to the LIS system. And the NeoIris comes with its own table because it's a bigger instrument and also heavier than the Echoluminar. We have here the cabinet where we have the liquids inside. Then we have on the left side the centrifuge, and here is our micro plate tower. On the NeoIris, we work with full microplates, not only with strips. And we have here our pipetting system, and we have 2 pipetting systems. That means a left arm pipetter with 4 needles and a right arm pipetter with 1 needle, which makes it possible to run always 2 plates at the same time for pipetting, and makes it faster for the processing. Here is our loading bay where we load reagents and samples, and we can load here up to 224 samples at once to load on the instrument, but also there we have continuous loading. So also to show you a little bit more how the instrument looks like and how it functions. As said, we have here all the main modules for the instrument, and the samples get loaded into linear racks as well. And we can load many samples at once, 224, but also there the samples are only blocked for the time while it's pipetting, and then we can already take it out and load more samples. So everything is fully automated. That means we load our samples, we start the assays, and then also there we get our real-time results. Every result which is finished, we can check already on the monitor and check already the partial results which are finished and go on with that. So it's our high throughput instrument, but we also have a stat priority on the instrument. That means if we have an emergency, we can also define that on the instrument and call it the stat sample, and then it gets prioritized for the other samples. So for the results, you can always check all the images as well, not only the final result. And we also have a lot of process controls on the instrument, in combination with the normal QC. And the instrument can also be connected bidirectional to the LIS system. Okay. Good. So yeah, my problem, I'm sorry for that, but my problem is as soon as I let new people in the meeting, my presentation gets stopped. It's a little bit difficult. So okay, I can't do that at the same time. Sorry for that. I will open it again. Okay, so now we should be back. Okay, so the test menu on the Neo Iris, we have here also for blood grouping, ABO-RH, donor confirmation testing, reverse ABO testing. So for example, if you have a lot of platelet concentrates, you can also start only reverse typing if needed. Then we have RH-Cal phenotyping, but also extended phenotyping. JKA, JKB, Duffy A and B, big S and small s, and Celano. And there are also more assays in the pipeline, which will come soon for the automated platform, like M and N, and also further for the, let's say, super extended phenotyping. We have for IgG cross-match, IgG DAT, C3D DAT, weak D, and also CMV testing. And on the antibody screen, we have on the Neo Iris 3 different panels. There is a pooled cell panel for donor centers, a 2-cell panel if needed, and the basic panel, the 3 cells for the normal patient testing. For the antibody identification, also here we have our primary panel, and then our D-negative panel, and also an additional D-positive panel for further testing in the antibody identification. Additionally, we provide also IgG antibody titration for any alloantibodies or like anti-D or others to test the titer of the sample, and also ABO titration for mother and child testing for the platelet concentrates, or also for transplantation testing. For our assay technology, we have, let's say, two different kind of technologies. One is the hemagglutination and one is the capture technology. So hemagglutination is just, as we all know it from the bench, like in the tube, we pipette sample plasma and reagent RBCs, and it agglutinates if there's a reaction. If there's no reaction, then we have a cell suspension. And this is the technology for all ABO typing, for the Callan phenotyping. And we also have now, for many extended phenotypings, also monoclonal reagents, and also test these ones in hemagglutination. Then in general, for all the Coombs testing, we have our capture technology. And I will tell you a little bit more about that technology in a minute. And there we do all the antibody screening, the antibody identification, and also cross-match and DAT testing. Just to give you an overview about some turnaround times for the high throughput instrument. So we have for 24 samples, 44 minutes for an antibody screen, and 96 samples will be finished in an hour. If we talk about donor testing and look for the pooled cell test, we can run in 1 hour up to 184 samples. If we look just for some data for group and screen, so if we look for patient laboratory, that would be for group and screen 48 hours, 48 samples per hour, and for donor testing labs with a pooled cell screen, it would be 69 samples in 1 hour. So that's also the highest throughput we have on the market. For type and screen, and we have a lot more throughput data if you need to know the turnaround times. That is just an example to show you how and get a feeling how the throughput is. If we talk a little bit more about the technology, we have the hemagglutination in the microtiter plate. So that means just the direct agglutination of the RBCs with the reagent, and if there's no agglutination, we will have a cell suspension like seen here in the anti-B, and if we have an agglutinate, then we have the agglutinate here like seen in the anti-A. The instrument will always give you the grading from negative to 4+, and also provides you already the final interpretation. So there is no need for the user to interpret anything. It's already interpreted by the instrument. If we look for our capture technology, and that's maybe new for some of you, the capture technology is a solid phase technology. It's IgG specific, and in the capture test wells, the antigens are pre-coated in the microplate, and then we pipette the patient or donor plasma inside the plate and see a reaction finally in the well. we don't have any liquid reagents for that because it's pre-coated, and there's also an advantage with that. We can store the plates at room temperature and have a very long shelf life. So how does it look like in a positive test? We would have the indicator cells finally bound, not bound, and they get pressed at the bottom of the well. And in a positive reaction, we have here a binding of the cells, which will be shown as a layer inside the well. And it's a little bit for, if people are used to work maybe with the GeoCard technology, it's exactly, if you look from the GeoCard from the top. So that means we have in the Capture-R technology here our binding. In a GeoCard, it would be also the binding at the top. And for the negative reaction, we have the cell dot at the bottom of the well, what we have here as well. So it's just a little bit of rethinking if you are new with the technology, but yeah, that's quite easy because the instrument will do the interpretation anyway. So I would like to show you a little bit more about the capture and how it works.
The Capture-R test procedure is quick and easy. To begin, remove the capture plate from the pouch. Every pouch includes a humidity indicator to ensure product integrity. Bound and dried red blood cell membranes eliminate the need for liquid red blood cells. Capture list is added along with test specimen. A color change from purple to sky or turquoise blue indicates test specimen has been added as an additional process control. Once test specimen and capture lists are added, capture strips are incubated at 37 degrees. During incubation, antibodies and antigens interact. Once incubation is complete, a washing step is done. Washing allows for the use of less than ideal samples, such as slightly lipemic or hemolyzed samples. After washing, anti-IgG coated indicator cells are added. Test strips are then centrifuged. During centrifugation, indicator cells bind to IgG antibodies that are present. Now let's take a look at some results. In a positive test, the anti-IgG coated indicator cells bind to antibody-coated wells, forming an intact layer of cells on the well surface. The more antibodies present in the well, the more indicator cells that will attach. In a negative reaction, indicator cells have nothing to bind to, and they form a pellet at the bottom of the test well during centrifugation.
Okay, good. So this is how the capture technology is working. And
The capture.
So let's look a little bit more into it if we compare it with other methods. On the capture ready screen and also the identification plates, we have all the screening cells already fixed to the surface and dried. And that's a big difference to all other technologies, because in the other technologies, we have it always already, or we need to put it in the test as a liquid cell. Incubation is in all the different technologies. We have in the capture technology also a washing step, because we would like to wash away everything what is not binding specifically on the surface and to the antigens we are searching for. And we have anti-IgG as our anti-human globulin, and that's a monoclonal one to make it more specific as well. We have a centrifugation step in other technologies. We always see an agglutination for a positive result. In the capture technology, we have a binding. So our anti-human globulin is present on a red cell, and that one will bind on the IgG reaction. So that's the big difference as well. It's not an agglutinate, it's a binding of the cells with the anti-human globulin. And the reactions are therefore also stable in the plate. If we work on an automated system, we have anyway the picture available and we can review that at any time. So if we look for the stability, we don't have the situation that our cells get older anymore because they are bound to the surface of the well. And basically in our manufacturing process, we are destroying the RBCs, then we bind them here to the well, and then they are present and also therefore longer stable, and we have a shelf life of 12 weeks if we compare it to liquid cells where we only have a 7 weeks stability, or most of the time it's less when the cells arrive your lab, because after production it's 7 weeks in general. So the storage therefore can be also at room temperature. That means 1 to 30 degrees. You don't need a fridge for that. You can store everything just in your cupboard, but if you want to store them in the fridge, that's also possible. We don't need to take out all the reagents for our screen and identification from the fridge and resuspend it before we put it on the instrument. It's because it's already inside the plate. We just take the plate and load it on the instrument, and everything is available. So we have less reagent handling there, especially when we think about an identification test where you might need to use more than 10 vials for an identification. And here we just load the plate and everything is already available. For capture, we have a lot of proof sources and many publications available. If you are interested in some more background on that, we can share that with you. So especially the question is always about sensitivity and specificity. So there was a huge study done some years ago in comparison to other methods, and that's one we can highlight a little bit because it compared all the different vendors with each other and checked with many different antibodies where the sensitivity is. A good sensitivity is one thing, but we also want to have a good specificity, and this was checked in that study as well. So it was also checked, are we really avoiding unwanted positive results? Because if it's very sensitive, then we would think there might be more unspecific reactions. But also here we saw that there is no difference to other methods, or or maybe even better. We have also a monoclonal anti-human globulin, and we know also that we have right now in the oncological section a lot of new therapies with monoclonal antibodies where the patients get treated with them, and some of them are reacting with different anti-human globulin tests. And because of the monoclonal anti-human globulin we use with the IgG subclasses, we know that we have no interference in our testing with that one. So that's also a nice side effect for these new therapies. So if we look to the features we have in the technology and the benefits for you, all the cells are pre-coded for antibody screening and identification. This gives us increased sensitivity and specificity. The sensitivity is also increased because of this coating. As I said, the red cells are dried, and also the surface of the RBC is like broken. So we only have the membrane of the RBCs inside the well. And that also, with this broken membrane, we also make it more sensitive, because some antibodies, we know that from bench testing, needs a little bit of more help to get the binding. But in our technology, the RBCs are already wide open there, and that's also the reason why the capture technology is comparable to enzyme testing as well. So also there are some studies available if needed, where we have to prove that the sensitivity is very good and enzyme is not needed in that technology. No liquid cells, which we need to manage, and therefore also the increased shelf life of the cells. It simplifies the training, and we have less labor with it. There is no pre-dilution or preparation needed for the reagents. Everything is ready to use. We just put it on the instrument, and then we can start with it. So there is no pre-analytical errors with some dilutions or washing steps needed before. And it's also the same method for all the procedures and all the assays. So there is not a different method for all the different testing, because cross-match and antibody screen, titration, everything is working in the same technology. How can you use the products? With our small and mid-size instrument, the Echoluminar, with the Neo Iris for the high throughput laboratories, and also if needed, we have a manual capture workstation for the manual use. There we have a washing system, we have an incubator and a centrifuge. But for sure, also there we can go for more manual. So if someone wants to wash a plate with a bottle, that's also something we saw and we know that it's working. So also that is still possible. Okay, that was a short introduction about the instruments and our capture technology. So now I would like to go on with a little bit about the support we provide and what we offer to you. So we see ourselves as a strategic partner for you in the lab, and try to partner with you with innovation and provide all the reagents needed, automation, but also data management systems, and for further testing, also the DNA testing for the blood grouping. Then we have also an education program. I will show a little bit more on the next slide for that. And we also have some investments in our transplant diagnostic, where we acquired years ago the life codes and OrganEye. And additionally, we have also a reference lab in the US. So in case someone needs a reference lab to send some samples through, that's also possible with Immucor DX, where we can send samples, but also for special testing like K-sort, which is for kidney transplantation compatibility test before and after transplantation. So for our education and training program, we have different things we offer to you. So we try to organize in each region symposium or webinars like we do today with you. We have a newsletter we send with any news we have for your market, and then we have as well some general webinars where we invite all customers, and you can find all of these schedules on our homepage. So if you go on immucor.com, you can find all the webinars we offer, and there we have sometimes Immucor speakers, but also sometimes external speakers. So it's a nice mixture of Immucor and also external speakers from our customers, where we always present different topics. In addition to that, we have a Learn program. The Learn program you will also find on our homepage. If you go on immucor.com, then you can go on the Learn section. And this is a program where we store trainings for you, which are recorded, or also training courses where you can click through. It's available at any time for you because it's recorded, and there are also some case studies and different kind of trainings for each level of knowledge available. You can also earn CE credits if that's interesting for you, and make it available to everyone. So even if you have students, you can share that with them, and then you can register yourself and have a look to the training program. Additionally, we offer also lean assessments for the laboratory. So I try to make a very quick introduction about lean. Lean is the understanding to see where we can make processes more lean. That means we offer you to come to the lab, and if we have a new project, we can look how is the laboratory set up, what makes sense, where should we position the instrument, the bench, and should we change anything, and just check how the workload is, how the technicians are working at the moment, and seeing where we can streamline and improve the processes for the blood bank. So that's something where we have many countries lean certified people in our organization, and we can also support you with that. So finally, what do we have if we have an instrument installation? We, and here in combination together with our partner HSC, we have an integration plan for new installations. So if we have a new installation, first the engineer will come and install the instrument and perform the installation qualification, followed by the operation qualification to set up all the tests needed. Then there is an on-site instrument training for the users, and we also provide validation guides and test cases if our support is needed for that. And we have for each customer specific technical specialists for you in the service group. and yeah, offer also our validation support if needed to have yeah, a seamless integration into your workflow. So for the support, there is the field sales team available who yeah, help you to set up everything with the standing order for the reagent consumption and ordering, and help you to get started with everything. Then we have our application specialists who will help with the implementation and validation and also the workflow analysis, but also help later on if there are any scientific questions or yeah, user related questions for the instrument and the product. On our side at Immucore, we also have global support engineers. That means it's like a third level support. If there's anything where we need deeper knowledge for very difficult questions, there are also experts on our side to help with that. And for all the normal inquiries, there is a technical support and service available. And there's the group at HSC. All of them are factory trained. That means they got trained by us, and will support on-site the instruments in any case of any issues or for the installations and preventive maintenances. And then there's also the customer service who makes sure that the inventory is managed and you get all the orders you need. Yeah, we also got some very nice feedback from our customers for the service and installation program we have. So there is the NHSBT from the UK who yeah, went live with 8 Neo Iris. That was a huge project and in 2 sites. And yeah, also there we saw that the concept was working very well and had a very good integration there. And yeah, so they are quite happy how the installation went and how everything got set up. So yeah, for what's important, we always think what's important for you. So to have a partner with yeah, a long history and knowledge and innovation as well. For sure, we always want a high type and screen throughput in the laboratory for the blood bank, the stat capabilities and no interruptions if we have any emergency. And the ability to load just the samples and have a real walk-away system. So that means you just load all the samples and then you come back to read your results and finally release them to the LIS. We also offer some reflex testing. What is reflex testing? That means, for example, if you need to perform a weak D test for all the samples which are RHD negative, we can set up on our instrument itself a reflex test, and it will order automatically for any blood group which is RHD negative the weak D assay. Yeah, real-time results, we said that already, is important, especially when we talk about cross-match samples. As soon as the blood group is finished, we can see already the results, look for the yeah, right donor concentrates and match it to the right patient. We have control materials available for you, which can be run daily on the instruments. And if needed, we have also a validation panel, especially for the antibody screening. Sometimes it's difficult, yeah, when we start with a new project to find at one point all the different antibodies to validate the instrument. So also there we provide some more QC material like validation panels. And finally, we try to support you as much as we can. So yeah, why to choose Immucore? Yeah, the capture with the solid phase red cell technology shows increased sensitivity and with a good specificity in the serological testing. We have a standardized compatibility testing and also electronic record keeping, what is everything for the automated usage and the benefits we have with that. We also have everything barcoded, so there is no chance to have any mismatch because we use the wrong documentation and no transcription errors as well when we work in the automated system. And yeah, as said before, the cells are dried, it's stable because this monolayer inside the well is stable and really for a long time stable, and you don't have to worry to exchange the cells every 4 weeks to a new lot. So with that, I will close my presentation and then I will give the word back to Mahmoud, and we are there for questions.
Thank you. Thank you, Desiree. Thanks a lot for sharing the presentation. And I hope that everybody was able to see. My apologies for the slight disturbances because of the control here and there. So what I will do now is I will open the chat. So if anybody has questions, please you can ask in the chat. And we will try to answer as many questions as we can right now. Otherwise, we are planning that, you know, the email registration link that you all received. Any detailed questions you can please share over there, and any feedback that you have. And we are planning to have maybe a follow-up session, hopefully in the next couple of weeks. You know, then we can address more of the in-depth questions that you may be having. So please, if you have any questions, you can write in the chat and we will try to address at least some of them right now in the next 10 minutes, hopefully. Unmute. You can also raise your hand and we can unmute you so that, you know, if you would like, you can directly ask a question.
Yeah, I think the chat is still disabled, at least for me.
Check karo enable hua hai ya nahi hua hai chat. हाँ? इसको unmute कर दो. I think Waqar Saab, you have already raised your hand, so you can please go ahead and ask your question. Mohammad Waqar. Waiting room. Waqar Saab, can you hear me? Please go ahead with your question. You can either write it in the chat or you can just speak up. आपको unmute कर दिया है. देखो chat allow हो गई. Chat allow हो गई. नहीं अभी भी chat disabled आ रहा है. नहीं यहाँ पे chat disabled आ रहा है actually. Chat नहीं ये यहाँ पे मेरे पास chat disabled है. वो खाना chat कर ठीक. सुबह से हेडफोन मेरा नहीं है chat disabled है. Allow participants to unmute themselves कर दो. नीचे इसके नीचे allow participants to unmute. So if somebody wants, इसके नीचे वाला जो है ना, इसके ऊपर हाँ ये, so they can just unmute themselves. और दूसरा इसमें देखो chat option के अंदर यहाँ पर. So we have just allowed you to unmute yourself. So if you have any question, please you can just unmute yourself and ask.
जी एक सवाल है.
जी प्लीज, आप कहाँ से बात कर रहे हैं?
am Niaz Ahmed. I am speaking from Lahore branch.
जी, please
ये
go
जो
ahead.
इन्होंने कहा था बाई डायरेक्शनल कनेक्टिविटी टू LIS मींस, इसको जरा एलैबोरेट करवा दें प्लीज.
Yeah, Desiree, can you share a little bit more about what you mean by bidirectional connectivity to LIS?
Yes. So bidirectional means we have a two-way connection. So we receive the order list from the LIS system, and we are sending back the results to the LIS. So it's a two-way connection. It's not only sending back the results, we also receive the work list from the LIS. And it depends on which LIS system you have, and if there's maybe also the possibility to have the management of the donor concentrates with the LIS system, so you could maybe already match the donor samples to the patient samples. No?
Okay, we have a question on the group which is asking how can we perform cross-match as target cells are encoded in the wells?
Yes. Okay, for cross-match, so yeah, as we said, that was today a basic overview because we were a little bit short with the time, but I try quickly to show an image for that. We have for the antibody cross-match testing, we have the same principle in the capture method. And let me just share one image here. So share again. Yeah. Okay. So for the capture select, oh, that was not working. Okay, let me, sorry. Okay, now, so I hope you can see now the screen again.
Yes, please, we can see. Go ahead.
Great. Okay. So for capture select, that's our also in the capture technology, we have for the antibody screen already the antigenes from the red cell bind inside the well. For the cross-match weak D or also the DAT testing, we have here inside the well only antibodies sitting, waiting for human RBCs. That means the instrument will pipette the RBCs of the patient or the donor, depending on the test, inside the well, and they will bind here on the surface of the well. So if we talk about the cross-match test, that are our donor RBCs. So the instrument is pipetting a drop of the donor cells inside the well, and then they bind on the surface here because there are these antibodies sitting and waiting for it. And then we have in the next step the plasma of the patient, and it's exactly the same step like the antibody screening. So that's the only difference. We first have to provide this layer of red cells inside the well. Is that okay with the explanation, or do we need more? Okay, so if then I will just go on to the next questions. And so there was another question, how to identify the IgM antibodies through the capture technique. So the IgM antibodies, we are talking here for the capture technology about the IgG specific reaction. That means we are only searching for the IgG antibodies, and these ones are the ones which are also transfusion relevant. We are not searching for IgM antibodies. And that's basically also the technology the other methods have as well. So if you look also on, I don't know, on a GeoCard, for example, the cards also say they are IgG specific if we test in the Coombs testing. IgM antibodies, we will detect for sure for the ABO testing. If we do our ABOD testing or phenotype testing, there we are talking about IgM antibodies. But for the antibody screen and the cross-match, we are testing in IgG only. And then there was a second question for the sensitivity of capture method compared to the tube method. And this one we had also on the presentation before, I think. Let me just open the other one again. If we compare, so yeah, in general, I would say we yeah have a higher sensitivity in general to the tube test, because on tube we know that yeah it's very dependent also on the technician who is working with it. And there are some studies available, but I think we will not find too many studies talking only about the tube test itself. So if there's always a tube test compared together with enzyme or with PEG, something like this, to have a comparison about that one. But in general, the sensitivity is much higher because we are not working with the liquid cells, and our cells are, yeah, as said already, the membrane is open, and we can connect easily with all the antigenes, which are also a little bit under the surface of the RBC itself. Yeah. If there is an interest to see some abstracts and study for it, we can for sure look for that. So I don't have one here right now to share. What I shared before was the one study where we saw the, sorry, I have to.
Basically, just allow me to come in, and what I will do is two things. Number one, if you have any detailed questions, please feel free to write an email to the address from which you received your invitation regarding CME@HSC. So you can just send an email there and we can provide the relevant information, any studies or papers. And it's good that Desiree is kindly showing some over here as well. Number two, regarding this, so we will also be sharing a feedback form with the participants of the meeting today, so they can share their comments and queries. In any case, you will receive one form within maybe in 1 to 2 days. And number two, so Desiree, please continue with what you shared.
Yeah, fine. So yeah, I'm just showing that again for the study I showed. So there was only GeoCard tested. Yeah, if we see here, everything of these were GeoCards and the solid screen from BioTest test as well. But yeah, we have for sure also some comparisons with the tube test, but there are not many because we know already the GeoCard is higher sensitive than the tube test. And in general, all the solid phase technologies show a higher sensitivity than any tube testing. Okay, good. Then what else do we have? So sensitivity. Then okay, is hands-on training or demonstration available in Karachi? Okay, that's maybe a question for HSC. So
Yes.
I was.
So I will allow me to step in. So
Yeah.
what I will say is yes, we can arrange training hands-on and demonstration in Karachi. In fact, we had one training for the large instrument in the recent past, and we are planning another demonstration maybe by end of March or maybe sometime in the near future. So again, my request will be just email on the address for CME@HSE, and when you receive the feedback form, if you want any information, if you are interested in a demonstration, or for somebody from sales department to follow up with you regarding a meeting, so you can discuss in more detail for your requirements, please feel free to just get in touch with us. Number two, so maybe Desiree, you can just take up the question for the capture IgG sensitivity. The next question.
Good. Okay. Yeah, fine. So the antibody identification or screening limitation, capture only identify IgG antibodies. So limitation, not really, because we want to see the IgG antibodies. And finally, that are the ones you need to see if you want to have a transfusion, that the IgG antibodies are also the ones which go through the placenta, and that are the ones we are interested in. Yeah, so that's not a limitation, and that's exactly what we want to see in the technology, and that's what the technology is made for. No?
So Desiree, would it be fair to say that actually this is the strength of capture technology,
Yes.
that we are looking at the clinically significant antibodies and not wasting our time and resources on the clinically insignificant IgM antibodies in this case?
Yes. Yeah, and I just looked quickly while we were talking. So if I find quickly a study about comparison with tube as well, and that was one where, to show you that the solid phase is seeing more antibodies than we saw in other methods. So here, for example, we had a tube with GEAL and capture compared to each other. And here we have, for example, for anti-E, most of them were anti-E, C, and also KIT antibodies. And we know that for JKA and JKB, that capture is the most sensitive technology. So that is something you will read again and again when we talk about the sensitivity for capture, that you find a lot of studies and a lot of abstracts about the KIT antibodies, because that's something where capture is really good in detecting them in a very early state. Okay, so then we have another question here. What about antibodies? Are both type IgM and IgG like anti-M? Yes. So for these ones, we will detect it for sure, because the IgG component of the anti-M will react in the test, and then we find that one. Yeah, that's something that will not be missed.
So then we can say that what we are actually intentionally ignoring are the IgM only antibodies. We are going to detect IgG and we will detect IgG-IgM.
Yeah, but mainly we detect the IgG portion of the anti-M. Yeah, if it's an anti-M antibody, for example, we will detect the IgG portion of it. Yes.
Okay.
Yeah.
So if anybody has any other question, please feel free to ask now.
Direct Coombs test. Okay, yeah, for the direct Coombs test, it's basically the same way what we have seen for the cross-match test. So okay, I will go on. So for the DAT, it's the same. We use a capture select plate where only antibodies against human RBCs are available. And then we pipette the patient RBCs inside the well. They will be coated to the well. So they are here as a monolayer available. And then we put the patient plasma on it. and see if we have a reaction. Yeah, that's for the IgG reaction. And for the C3D test, we, if that's needed as well, we have an additional plate which is coated with a different layer which will detect then the C3D.
Yeah, I think somebody wanted to unmute and ask some question directly.
Yes,
by
please.
voice.
Please. Mhm.
Yeah. If you want to unmute yourself and ask a question, please go ahead. So we have another 3 minutes to go. So if anybody has any questions, please let me know. And at 4:30 Pakistan time, we will close this session. Okay, so I think
Oh, is this cost effective? Okay. It's a good question. Yeah. For sure, there are some costs on the test itself. Yeah, but the cost effectiveness is something where we need, yeah, always to see what we are testing. And for our tests, we are working on the microplate technology. That means we are working with a full plate for the testing. So it's a yeah, not only a high throughput, we also get a lot of samples on one plate. Yeah? And if we talk about the small customers, there we are working only with the strips. So that means if we only have one patient to be tested, we will use only one strip and not the full plate. So it's as cost effective as it could be. Yeah, and I'm pretty sure if you need an offer for that, then you can get that from Mahmoud and the team.
yeah, I think I would just like to add that in principle, definitely when you go for automation, it has many advantages, but of course it will come with some cost as well. And then again, you will need to, you save a lot of time and resources, and you reduce all the human error that is possible. You have all the electronic records. So these things Desiree has already gone through earlier in this presentation. And other than that, like she said, the cost will purely depend on your particular institution, your workload, how much you start or you work in terms of batches, and the specific test and the mix that you have. So we will be more than happy to discuss this in more detail. If you can just, like I said, you can just contact our sales representative or just email us from the invitation that you received, and then we can sit together and discuss in more detail. And Desiree, you can share about the time required for the cross-match test.
Yeah. So there's always the question how much we want to test. And if we talk about the high throughput instrument, one sample with a handful of donors will take about 30 minutes. And on the small or mid-size instrument, we have 28 minutes. And then it depends how much more samples you want to do. And that's also the nice feature we have with our high volume instrument. So if we have, let's say, about 50 donations to be tested at once, we also can start that on the instrument in one run. And the time on the high throughput instrument is not much longer for a high number of samples in comparison to only 1 or 2 cross matches, because it's only the pipetting time which will get longer and not the full test, because it's still on one plate. On one full capture plate on the Neo Iris, we can run 92 samples at once. So yeah, that's a lot, and I don't think that any lab has a big batch like this during their daily work. Okay, there's another question for the weak D assay. So it's good that I have still this picture open from the presentation, because it's exactly the same. Again, we have a capture plate, which is only coated with antibodies against human RBCs. And
actually, Desiree, the screen you're sharing is sensitivity for detection of antibodies. I think you're sharing another slide.
Okay. I see that okay, let me stop and start again.
Yeah, so you can just share the right slide that
Yeah.
you're talking about. So
I
that
thought it, because for me it looked like I was still sharing this. So see,
yeah,
you
yeah.
found
Now
it
it's the right
now?
slide. It's the right
Okay.
slide.
So here we have the antibodies again sitting in the well and waiting for their human RBCs. So for patient or donors, we take a drop of the RBCs, or actually not really a drop, it's just some microliters, and we make a cell suspension with the RBCs from the sample pipetted into the well, and then the RBCs of the sample are binding to the antibodies in the well. And in the next step, we put our anti-D reagent, 1 drop, and also the LIS reagent as a potentiator inside the well, go to the incubation, and then we put our anti-human globulin on top, and that will bind if there is a weak D present, or it will not bind, and then the cells will be just pressed to the bottom for a negative reaction.
If I may add over here 2 things. One, like Desiree already you said earlier, that weekly is not just available, but it is also available as a reflex test. That means if you tell the machine beforehand, once there is a negative, D negative, then automatically the machine will go and test for weak D. And I think further, this is one of the another advantages of our system, that you can actually configure that if you want to work with 1D or 2D variants or 2D clones. So, you know, that again is another strength of the system and the flexibility that we offer.
Okay, there's another question in the chat for Bombay blood. Okay, so yeah, Bombay blood is difficult in general. What we have and what we can offer, we have a lot of different setups for the blood group. So the example you see here is an example from Germany where we test anti-A, anti-B, 2 times D, A1, A2, B, and O cell. So in Germany, they do the full package. They test all the reference cells we have. So that's something we can offer to provide also an A2 cell and O cell in addition. And then for Bombay blood, we know how it's reacting, then everything might react. And the point is, our instruments are always checking if the anti-sera reaction, for example, for anti-A, is reflecting the reactions we have in the reference cells. So what does it mean? In case we have here the anti-A positive, we always expect that the B cell is positive as well, because that's what is normally the case. And for all blood group, it would be the same. If anti-A and B is negative, we would expect here reactions in the cells, in all cells except the O cell. So that is a possibility what we can offer. The reference cells is a 4-pack with A1, A2, B, and O cell. And yeah, then finally, I think the Bombay blood needs to get tested further as well. Yeah, that's what we usually do. Then it goes for molecular testing in most cases. Yeah. Additionally to the normal anti-A and B or reference cells, we also offer a subgroup test where we test anti-A1 and anti-H together with the RH control.
Sure.
Also to see some sub blood groups of the A blood group.
So Desiree, if I may say, would it be correct to say that the system will flag the result as you know, something to be investigated further?
So
if it's a suspected Bombay.
Yeah, the instrument, if it will not match the anti-sera reaction, the forward typing to the reverse typing, the instrument will give you a result which is interpreted as called NTD. That means no type determined, and will highlight for the user in red already that there's something unnormal with the patient, and that you have to look to that and check the results. Yeah.
Okay. Okay. So I think somebody wanted to ask one more question, then they had unmuted. You can please unmute yourself again. I think it was Mr. Amir Wakas or somebody, Mr. Irfan Yusuf. Yes, please. how much cell concentration we are
yeah.
using in the system.
I wanted to say I don't hear something, but meanwhile, yeah, if someone wants to unmute, you can do. Otherwise, I just go on with what I see. So the cell concentration. Okay, so we have to differentiate here from assay to assay, because in our cell concentration for the reference cells, for example, for the reagents is 2 to 4%. That's what we use in the reference cells. Our cell concentration in for the sample where we make the suspension in the instrument itself is around 1%. So we use usually for the red cells only 3 microliters and diluted inside the instrument itself.
Okay.
And
So,
for titrate, I'm not sure if that's important, but for titration, for example, we use liquid cells, and they also have a 2 to 4% red cell concentration. Yeah.
okay. So I think at the end now.
No, it goes on, Mahmoud. So are we using LIS? Yes, we do. We use also a LIS reagent in our Coombs cell testing for screening, titration, identification, cross-matching, weekly testing. And our LIS has also another benefit. It's a purple colored LIS reagent, which we use in the automated system. And we use this purple color because there's an indicator inside. And as soon as this purple LIS will come together with the proteins from the plasma of the sample, it will have a color change. That will give us also the possibility to check if LIS and plasma are really together inside the well. And I said briefly before, there are some process controls and safety features in the instruments, and that's one of it. So we always check that LIS and plasma are really pipetted and everything is where it is, because if you imagine, for example, you have a sample where the sample material is almost gone, then you have only RBCs maybe left in the sample and you test it on the instrument. And we really want to see that we pipette the right material and plasma in the antibody screen testing and not the RBCs of the patients. But yes, we use LIS and it's called Capture LIS.
Okay, great. So thank you again. And yes, thank you, Mr. Waqas, also and Waqar, and for all your questions. And everybody, thank you very much for sticking around. I'm happy to see that most of the participants are still available, and they were, this is showing that, you know, there's a lot of interest. And thank you very much for Desiree for sharing all this valuable information today. And I would request everybody, please, hopefully by tomorrow, you will be receiving an email from us regarding the feedback and questions and queries that you may have. And we would surely be very happy to come and visit you directly or have a separate session with you or your institution directly to address any queries and requirements that you may be having. Thank you again, Desiree. Thank you all the participants for joining today. And I wish you a great day and looking forward. Thank you. Goodbye.
Thank you.
Assalamu alaikum.